So problem number 18, in the expansion of this binomial to the 12, the constant is equal to this fraction. Find the value of k. Okay, guys, so let's write down this binomial to the 12. There you go. Yeah, okay, that's right. And let's write down the first few terms. Let's write down the first three terms of the expansion of this one. So we're going to have 12 choose 0 times x to the cube to the 3 to the 12 times k to the x, I'm sorry, k over x to the 0 plus 12 choose 1. Just gonna be quiet and do this. I'm gonna write another one. Like so. Plus, etc. How many terms do we have in the expansion? We have 13 because this exponent is 12. Okay, so they tell you guys that constant, one of these terms, either the first one or the second one or the third or the fourth or any of the remaining terms will be constant. What does that mean? It means that its variable part will be raised to the zero, basically, which is equal to 1, right? So that the variable part disappears and all you have is a constant. Okay, so if we consider only the variable parts, I'm going to write VP, variable parts of these terms. Let's take a look at that. When you raise x to the cube to the 12, you're going to have x to the 36, right? And when you raise this to the 0, you're going to have 1. So the variable part of this term is x to the 36. If you don't believe me, simplify this whole thing to its maximum, and you will have some coefficient, I don't care what number, times x to the 36. That's going to be the simplification of this one. Some number times x to the 36. That's why I say that the variable part of this term, which is this, is just this part, x to the 36. Okay? What about this one? Look at just the variables, x to the 3 to the 11. That's going to be x to the 33. And then you have this other variable part in here. So you have k over x to the 1. So you can have k over x, right? And when you multiply this, you're going to have k times x to the 32, lots of exponents. So the variable part of this one is going to be k times x to the 32. And what about this other? X to the 3 to the 10, that's going to be x to the 30. And then this to the square is going to give you this. Multiply these two, and you'll have k to the square times x to the 28. Am I correct? Yes. Okay. And see the pattern. See the pattern, guys. X to the 36, that's for your first term. X to the 32 for your second term. X to the 28 for your third term. What do you think will be the variable part of this term once you simplify it to its fullest? It goes down by 4, the exponent, I mean. 36, 32, 28, x to the 24, okay? And you keep doing this until you finally, I mean, you don't have to do this process, just go down by 4 until you eventually reach x to the 0, okay? So it's gonna be how much? 1, 2, 3, 24. first term, second, third, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is the number of term. This is the first term. This is the second term, the third term, the fourth term, and the variable part is x to the 36, x to the 32. Now, I'm sorry, k times x to the 32, and then k squared times x to the 28, and then this one will be k to the cube times x to the 24, and that's it, guys. Just keep going down, and just observe the pattern, right? The exponent in the x decreases by 4, and the exponent in the k goes up by 1. So this one will be k to the 4, x to the 20, k to the 5, x to the 16, k to the 6, x to the 12, x to the 7, k to the 7, x to the 8, k to the 8, x to the 4, k to the 9, x to the 0. And this is the one that we wanted, because in here the x will disappear, right? This is going to be 1, and you will just have k9 in the end. Okay, so it's this one, guys. The number of term, variable part. This is the good one. It's going to be the 10th term of this expansion. So you see, you don't have to keep doing this. Just, let's say, like, write enough so that you can spot this pattern, right? And then once you have done this, and once you have localized the term that you actually wanted, then let's actually write it down. So we are hunting for the term number 10. So let's erase all of this. Okay. So the term number 10, this is the first one, second term, third term, fourth term, and we're looking for the 10th. The 10th term. Okay, so it's gonna be 12, choose 9, right? 12, choose 0, because this is 1, and so we can see that this is 1 less than this, always. Can you see? So if I'm looking for the 10th, this should be 12, choose 9, because this is 1 less than the number of term. You see, guys, it's just about exploring patterns. And then x to the 3 over 3, to what exponent? That's going to be 12, wait, give me a moment. 10th, 11, it's going to be to the 3, if I'm not mistaken, because of this. Look, let me write the other one, and this should be 12. No, I'm sorry, this should be 9. This should be 9. Yes. Okay. Looking here, the sum of these exponents, guys, always gives you this exponent. You see, 12 and 0, 12, 11 and 1, 12, 10 and 2, 12. So how did I know that this exponent and this exponent are these ones? Well, if I'm looking for the first term, look at the exponent in this second factor, 0. Second term, the exponent is 1. Third term, the exponent is 2. You got it? So if I'm looking for the term number 10, then this should be 9, and therefore this should be 3. So that 3 plus 9 respects that rule of being equal to 12. So this is it. This is the term. This is it. Now it's just a matter of simplifying. 12 choose 9. Let's go calculate that value. Combinations, 12 choose 9. That's gonna be 220. 220, and then Let's do the whole thing. X to the 3 to the 3, that's going to be x to the 9. 3 to the 3, that's going to be 27. K to the 9, that's going to be k to the 9. And x to the 9, that's going to be x to the 9. We already agreed that this is going to cancel this one. And you're going to have 220 over 27 times k to the 9. So that's the 10th term. And that's the one that is constant. And is equal to this fraction. So let me do that in red over here. So this term is equal to this fraction. Okay, we multiply both sides by 27. So we get this 640. And I mean, it's just an isolation of k, right? Um, this is going to boil down to k being equal to this number over 220, and we take the root of index 9, and that's the closed form. That's the this is the correct solution, or the perfect solution, or the exact solution. Okay, and if you want to go look for an approximation of this number into decimals in case you need it for some reason, okay, let's go do it. Let's open the TI, and let's go here. Okay, well, you're gonna do the following. Let's open the structure for the index, which is right here. There you go. The 9th root of this fraction. Let's open the structure for fraction. 112,640 over 220. And I'm not gonna press enter. What I'm gonna do is an approximation of this into a decimal. So I'm gonna do this. I'm gonna press Control and then enter. Oh, it's actually a perfect solution. That's nice. It's 2. All of this is 2, guys. Okay, this is actually a perfect number, a perfect integer. So it's 2. So that's it. K is going to be equal to 2, period.